Ryan, please say us what is turning effect? Huh? Ryan,
Sure.
Ryan, can you say what is turning effect of force?
Um, Not really, sir.
I gave the definition in last class. You wrote it, right?
Oh, that's
Yeah, you have to write. Huh? Today you write. Turning. Write the topic name. Topic 5: turning effect of forces. Then Anmol, you wrote what is turning effect of force?
Yes, sir.
Yeah, say.
So turning effect, if we apply force on an object about a pivot, then it turns.
Hmm.
This effect is known as turning effect of force or moment.
Very good, very good.
Sir,
Then
you gave one example also. In our
yes.
everyday life, you use many instruments,
seesaws,
objects,
fans.
devices, which we get turning effect of force to get benefits.
Hmm.
Example, stapler, scissors, crowbar, punch machine, door hinge, etc.
Okay, so could you do one favor for us that you send the snap of this writing in our group? Is it possible?
Yes, sir.
Sir, there is already a screenshot.
Yes, sir. I gave a screenshot. I can give that
Now,
again.
now please also send your writing so that Ryanjit and any other student they missed it, they did not write it, they have to write. Okay,
Okay, sir.
Ryan, please write. Huh?
yes, sir.
I
Okay.
I need your feedback also. I only say something and you will listen, you will go. That's not enough. You also have to apply those ideas. So uh, this one also coming sometimes as definition in your exams. What is called turning effect of force and where we apply the turning effect of force. This way, sometimes you have to, uh, you know, use your ideas, execute your ideas. Now, Maruf. Hello, Maruf. Hello, Maruf.
Yes, sir.
Yeah, we expect all the students will participate in class, and we want everyone's effort to make the class a success. Okay, only few students they will participate, and only they will take part in discussion. That's not enough. Yeah. All of you are attending. All of you are part of our class. So all of you should do work, right? Please do it, huh? Maruf, you
Yes,
got
sir.
one idea in last class that turning effect of force or moment, that one we get more if the distance from the pivot is more, right? Isn't it? Hello, hello. We gave many examples, we gave the example of spanner, crowbar, stapler, that where the distance from the pivot is more, then it's easier for us to do the work, do the target work to get the output, isn't it? So, are you listening?
Yes, sir.
So so the turning effect or moment is depending on two things. One is force, another one is distance from the pivot. Is it clear to you? uh,
Yes, sir.
we we are getting the formulas. For speed we got the formula, for density we have got the formula. Now we will also get the formula for time. So how the formulas are coming, we should look up on there, right? We should go deep into there. That sometimes you are writing spherical distance over time, sometimes you are writing that work done equals force into distance move. Why sometimes you are multiplying, sometimes you are dividing? There is reason. So here we are getting turning effect of force or moment. That time we are multiplying. we are multiplying because both the you know both the variables here, force and distance, any one of them we increase, then turning effect of force or moment will increase. Okay, is it
Yes,
clear?
sir. Yes, sir.
So here we got the idea here. You see, we have formula
Sir,
formula of
can you
moment.
excuse me
Yeah,
for 1 minute?
sorry.
Can you excuse me for 1 minute? Actually, I have some important work.
Okay, okay.
Thank you,
So
sir. You
what
can continue.
what yeah, what we were discussing, that moment or turning effect of force, we are getting more the distance we got the practical life experience, like when we are closing the door or opening the door. If we are applying force very close to the hinge, then it's it's taking more force, right? We require more force to open or close the door, isn't it? And if the distance is more, then it's easier for us to open or close the door. That means we are having more turning effect or more moment if the distance from the pivot is more. Same as force. If we apply more force, we will have greater turning effect, isn't it? Hello, hello. Are you listening, everyone?
Yes, sir. Yes.
So
Yes.
this way, we understand we have to multiply both force and distance from the pivot, perpendicular distance from the pivot, to get the moment. So you write here only. You don't write everything. Whatever I am writing, you write that part only. You write calculating moment. Moment means turning effect of force. You also write in bracket effect of force. Turning effect of force. So we have formula of moment here. Moment equals force
Into
times
distance move.
distance, perpendicular distance. You uh, specifically you write it perpendicular distance from the pivot.
From the pivot.
Yeah, why it is perpendicular distance? You will get more details in A levels. Now just write this one, that perpendicular distance from the pivot. So moment symbol is R, that equals force times D. Moment is a vector quantity, and its SI unit is, you from the formula we understand that the unit is coming Newton meter, right? Force is Newton and distance is meter.
Meter.
Yeah, so it's Newton meter, huh? Newton meter is like this, Newton meter. When there is multiplication with two quantities, we write the unit with little bit hyphen, okay, so that understand it's the product of these two multiplications, force and distance, and this way. So this is very fundamental things about moment. You should remember this formula, and you should also remember this one, perpendicular distance from the pivot. Okay, so are you done with this writing?
Yes, sir.
Yes, sir.
Hmm. Where is this? Here. Okay, you take a snap from here and send it, huh? Have you taken snap? Hello?
So I have taken. I have written the notes.
Yeah. Yeah, Anmol or anyone, you just send it now, huh? In the group. Who has the access to send?
Sir, the snap or the note?
The
Sir,
send,
done.
the snap. Snap is better now. Okay,
Sir,
when
done.
snap is available, that time snap is better. Okay, now, yeah, we have with us uh, Mithila, then Taki, we have Maruf also. So, have you understood, all of you? I am also only getting sounds from only
Yes,
Anmol,
sir.
Adrita,
I understood.
then Lamisa, these three. But you also should respond. You have any question, you should let me know.
Sir, I understood.
Very good. Okay, so we have here one condition. You see, we have a pivot here on the pivot. We have a plank of wood, and left side we have a stone. Then right side we have a weight. We are having this wooden plank balanced.
Sir, 0.8 plus
Yeah.
4.0
So
into
the
24.
hmm, the you see, from the stone, the perpendicular distance of the pivot is 0.8 meter, and the weight of the stone is 24 Newton. So you can find the moment, right? The moment created by the stone.
Yes.
So first you find that today we don't have Basha with us. What about Basha? Huh?
Then he
Okay,
Sir,
go
there is no
some
quick
problem
electricity
with
in this
question.
area.
Was Batra present in any of
No,
Moment.
no.
first classes?
So moment you write first.
Only.
Moment created by the stone equals force. Force means weight, right? We know
yes, sir.
weight is one kind of force. So we have here 24 Newton multiplied and the distance given over there, it is 0.8. From the pivot, the perpendicular distance is 0.8 meter. So the moment for the stone is coming, calculate and tell me the answer.
19.2 Newton meter.
19.2.
2 Newton meter. Okay.
Yes, sir.
Then there is a little extension of the question. There is calculate weight of the metal block. You see, we will get this idea later more in more details. That here for the stone, we have one moment, that is making the stone to turn, or the whole system to make turn anti-clockwise, isn't it?
Yes, sir.
Everyone, are you understanding?
Yes, sir.
Like if the weight that one is W is written, labeled as W. If it is not there, then what would happen? Everything, all together, the stone, the plank, everything will turn anti-clockwise, and the stone will fall down, isn't it?
Yes, sir.
What about others? Are you understanding? At least you should say yes, sir, or we understood. Yes. Anmol, Maruf, Mithila,
Hello, sir.
are you
Can you
understanding?
hear me?
Yeah.
Yes, sir.
Yes,
So
sir.
please respond.
Yes,
When
sir.
when I'm saying have you understood, you should respond yes or no or anything else. Then I may get confidence that yes, you are listening and you are
Sir,
understanding.
I couldn't unmute myself.
Okay. So we have here anti-clockwise moment, the left one for the stone. That one is balanced with the weight. You see the weight is working in a way that the plank weight, this whole system, that's working clockwise, right? So the weight is creating clockwise movement. So the weight is creating clockwise movement. This clockwise movement is uh, helping.
Sir, how? Like how the weight is creating clockwise moment?
Yeah, that is really great. I expected this question. When you ask me question, that I get confidence. Yes, you are listening. Okay, look, here we have the first one I show you. Here we have 24 Newton, right? And this is stone. So my first question was, if the weight is not here, like this weight, which one is labeled W, is not there, then what would happen? Then what would happen?
The stone will not be balanced on the pivot.
Yes. Then what would happen? The
It will
tank,
fall down
yeah.
Will fall.
How? It will fall down. It surely fall down. But
in
how it's
clockwise
falling?
in clockwise
It's yeah,
direction.
yeah. That is anti-clockwise direction. That is
Or
called anti-clockwise. You
counterclockwise.
see?
Yeah,
Yeah,
anti-clockwise.
yeah. You see opposite
Oh
of
yes,
clockwise. Yeah. Right? Now you understood?
Yes,
yes.
sir.
Now I understand.
Yeah. So the right side one is opposite. That's creating the moment which is clockwise. So one moment is anti-clockwise, another moment is clockwise, and these two are equal. Yeah, these two moment are equal, not force. We are not talking about force. Listen, don't mix up. Moment means product of force and distance. Here, very simple from our common sense, we understand that here the distance is more, distance is less, and the right side distance is more. That's why when we'll have the product of force and distance, that one same or equal for both sides, then we understand obviously W, the weight labeled here, that will be less, right, than 24 Newton, isn't it?
Yes, sir.
Have you understood, everyone? And now we will get that proof. Now we will get that proof. Okay, so here you write it in bracket, you write it anti clockwise, huh? Okay, have you written?
Yes, sir.
Yes, sir.
Okay, now you write moment created by the weight W, huh, is equal to what? We have here distance given. Let us check the distance. What is the distance given here? Can you remember?
The distance,
4.
it's 4.
Yeah, 4. I'm making it a little bit smaller so that you can see all together everything.
Sir, if you make it smaller, it will just make it harder for us.
Oh, really? Oh, then
Oh, no, no.
is it fine?
Yes, it's fine.
Okay, because we focus in the diagram, the other things, other writing already we know. So if you get the diagram all together, it's making it more easier to understand, right? Now we have weight. Then we write here a weight force. Force means what? Weight, right? Weight of the object, that one. Force
Sir,
multiplied. Hmm.
the weight is same, right?
No, we gave you one thing like the distance is
Like for
more.
the stone. For the stone. That's what I'm
For the
asking.
stone you have 24 Newton, but for the W, that one label W, the mass given over there or the weight given there, we have to find that one. Okay,
Oh,
we have
okay.
to find that one. So here force means weight, actually that one, right? We label there W, that one is our force, right? So perpendicular distance we have 4, right? 4 meter, huh? Okay. Now we have yeah. What is the moment?
Sir, 19.2
Yeah,
Newton per.
19.2, because this object is balanced. Yeah. So we are having the moment anti-clockwise. The clockwise moment will be also the same, right? As it is balanced. Okay.
Yes. Yes, sir.
So we are right here 19.2 Newton meter. then divided by 4 meter,
4.8.
then equals W, right?
Yes.
Then W becomes 19.2 divided by 4, how much?
4.8
4.8.
4.8 Newton. So
Newton.
we got the proof,
Clockwise.
yeah, we got the proof that here the weight of the force is less, right? Isn't it?
Yes. Yeah.
The right side we are
Sir.
having right
Sir.
side we are having less force as we
But
have,
the distance is more.
Answer is 4.8.
yeah, answer is 4.8 Newton. So
Okay.
it's clear, right?
Yes, sir.
Answer. So you can have a snap from here and send it to group, huh? Please.
Sir, done.
Okay. So we are done with this part. In next, we are having more discussion on it, huh? More details on it. Now the time is 11:10, right? Hello.
Sir.
Yes, sir.
So you join after 5 minutes, huh? For the
Okay,
next
sir.
class, we will
Okay, sir.
discuss more in
Okay, sir.
next class. Let's have a break, 5
Okay,
minutes.
sir.
Huh?